Hi everybody, Mrs. Pesic here. We're looking at section 1.7, transformations of functions. Your learning objectives are to use vertical and horizontal shifts to sketch graphs of functions, use reflections to sketch graphs of functions, and use non-rigid transformations to sketch graphs of functions. In this section, I have 3 goals for you. The first goal is to be able to look at the equation of a function, identify the parent function, identify the transformations from that parent function, and to be able to sketch an accurate graph by hand. So for example, if you're given this function, f of x equaling -3, x minus 2, quantity squared minus 6, you'd be able to say, oh, my parent function is f of x equaling x squared. That was one of the parent functions from our library of parent functions in the last section. But then you would go further than that and you would be able to identify the transformations, like what's going on with this minus 2 here? What effect does that have on the graph? What about this 3 here? What about the fact that it's a -3? And what about this minus 6 back here? All of those are going to transform our basic parent function, which is just this parabola with its vertex at 0, 0, but somehow that parabola is going to be shifted left, right, up, down. It might be reflected over the x-axis. It might be stretched or compressed. So those are all things for this first goal. My second goal for you is to be able to look at the graph of a transformed function, like this example here, be able to identify the parent function, and to be able to write the function that would produce that graph. So looking at this, I'm hoping that you would be able to say, by the end of this lesson, that looks like a square root function was the parent function. So parent function in this case is f of x equaling square root of x. And hopefully you remember that that graph from our work in section 1.6 looks something like this. So this graph is similar, but it looks like it has been reflected, perhaps, over the x-axis. Let me see if I can just flip this. Flip. So it's been reflected over the x-axis, so now it looks like this, but then it looks like it's also been shifted from where it was 0, 0, it's been shifted to the left and up. My graph's a little bit off, but you get the idea that there was a reflection and some shifting. So you would be able to write the parent function, you'd be able to write the new function that would describe this graph here. That was my second goal for you. My third goal is for you to be able to write an equation for a function that is described by a set of characteristics. For example, let's say you want the shape of f of x equaling x squared, but you want it to be moved 2 units to the right, 5 units up, and reflected in the y-axis. So that's an example of looking at a description of a function and then being able to write the equation. So that's my third goal for you in this section. All right, so let's start off by just predicting how g of x and h of x will differ from a parent function f of x. So if we have the parent function f of x, and again, I'm hoping that right now you already have in mind, in your mind, a picture of what this parent function looks like. It's this kind of shape for f of x equaling x squared. It has this kind of squiggle shape to it, and it does go through 0, 0, and it is symmetric about the origin. All right, but what happens if we have x cubed plus 2, like in this example? Well, you can maybe make a prediction about what that graph is going to do, but let's check on our calculator. So if I type in our parent function, x cubed, all right, there's that squiggle kind of graph. But now we want to see what x cubed plus 2 is going to look like. So I'm going to push tab, and I'm going to do x cubed plus 2, x cubed plus 2. Well, what's happened to the graph? Well, what's happened is the whole graph has been shifted up 2 units. So that plus 2 at the end of the function has shifted the graph up 2 units. All right, what if we have x plus 2 quantity cubed minus 1? Let's see what effect that would have on the graph. This time we want x plus 2. So I'm going to get rid of this last function that we had. We want x plus 2 in parentheses raised to the third Okay, well, let's just start with just that much. What happens if I have x plus 2 raised to the third? Well, that has shifted the graph. Did you predict this one? X plus 2, quantity cubed, does not shift it to the right. It shifts it to the left 2 units. And then we wanted to continue and have this to be x plus 2 quantity cubed minus 1. So let's get that function back again. I push tab, I did an up click, and I want it to be minus 1 here. So that shifted it 2 units to the left and now 1 unit down. So that point, we would call that the inflection point, where it changed from kind of facing downwards to facing upwards as far as like a bowl shape, is now over at -2, -1. All right, so that can hopefully help you understand what's going on with shifting left, right, up, and down. And let's kind of just, before we move on, let's kind of generalize this. So if we have f of x as our parent function, whatever that parent function is, and we have a new function, let's say g of x equals f of x plus c, where we take the function, we add something to the end of the function, then that is going to be a shift up c units. All right, and if it's a minus c, it would be a shift down. C units. All right. Let's look at, what about the shifting left or right? So if I have g of x equaling f of x plus some constant c, for example, now I'm putting the x, I'm adding c to the x before I plug it into the function, then that is going to be a shift left c units, like we just saw in that last example. And if we have g of x equaling f of x minus c, again, where c is some positive number, if we're subtracting a positive number from x before we plug it into the function, that would be a shift right c units. All right, let's experiment with this a little bit. Let's go back to our calculators. I'm going to add a new page to our document. Let's play around with a different function. Let's say, for example, we're going to do x squared as our parent function. And let's say this time we want to shift it to, let's say we want to shift it to the right by 3 units. Well, I can push tab, and I'm going to shift it to the right, means I need to do x minus 3. That's going to shift it to the right, I hope. And then squared. Sure enough, x minus 3 squared is going to shift it to the right. And if I wanted to shift the original graph to the left 1 unit, for example, I could just do parentheses. I want to go to the left. It's going to be x plus 1 quantity squared. That shifts it to the left 1. So let me slide these over so that they're with the parabola that they represent. All right. Anytime you want to shift a graph left or right, you're going to add or subtract the appropriate number in with the x before you square or take the square root, and so on. All right, moving on. Let's talk about reflecting graphs. All right, let's take, for example, our parent function f of x equaling absolute value of x. You know that parent function looks like a V shape. That's the absolute value of x, V shape. Well, what happens if we take that function and we want to change it to the opposite of absolute value of x? Let's see what that looks like on our calculators. So we're going to add a new page here to our document, and I hope you're going to save this document as like 1.7 notes. We're adding a graph here, and let's do absolute value. Remember, we do ABS for absolute value. And if I do ABS, absolute value of x, there's that parent function. That's that V shape. And now if we want to do opposite of absolute value, I'm pushing tab, and I'm putting in opposite of ABS of x, right? What happened? Well, the function got reflected over what? It got reflected over the x-axis. So when you take the opposite of a function, you're going to get a reflection over the x-axis. So g of x is a reflection of f of x over the x-axis. In general, if h of x equals the opposite of the original function, then h of x is a reflection of the original function over the x-axis. What about if we have h of x equaling f of the opposite of x? That's not the same. These two things are different from each other. So let's experiment with that. Let's add a new page to our document. New graphs page. This time I would like to try the square root graph. So let's do square root of x. There's our parent function for square root of x. And let's say we wanted to make this well, let's experiment with the negative in front first, because we saw that that was going to reflect over one of the axes. Let's see. So if I do tab and I do a negative in front of the square root of x, there's that reflection over the x-axis. So if I put that negative in front of the function, then it's going to reflect over the x-axis. What if I put the negative in with the x? Let's see what happens there. So I'm going to go back up. I'm going to take out that last graph, and I'm going to make it square root of negative x instead. Now what happened? Square root of negative x has reflected it over the y-axis. So if you take every x in your function and you make it the opposite, you're going to get a reflection over the y-axis. All right, and that's what it says right here. If h of x equals f of negative x, then h of x is a reflection over the y-axis. So hopefully you're following along here. If h of x equals the opposite of our function, then we're going to have a reflection over the x-axis. And if h of x is equal to f of negative x, then it's a reflection over the y-axis. All right, so we just did these. We just compared these on our graphs. So hopefully you remember what happened. So if I have g of x, if I have that x, if I make the x negative itself, that's going to reflect over the y-axis. That was that latest graph that we did. And the one we did before that was this one. And that was a reflection over the x-axis. All right. So let's take a look at this. Let's predict the change from f of x equaling x to the fourth to g of x equaling the opposite of x plus 2 to the fourth. Let's just start with that first example. So if you see opposite of x plus 2 to the fourth, we know our parent function is just x to the fourth. And so what happens if we do x plus 2 before we raise to the fourth? That's a shift. What direction is that a shift? Up, down, left, right? Well, I hope that you remember, and we can check this on our calculators, but I hope that you remember that if we see an x plus 2, that's a shift to the left 2 units. And we're going to verify this in just a moment. And what about the negative in front? If the negative's in front of the whole function, that's a reflection over the x-axis. So let's take a look at this on the calculator and see if this is actually true. So I'm going to add a new page, new graphs page. Let's get that parent function there. That's x raised to the fourth. And this one, it actually looks very much like x squared, except it is going to be steeper along the sides and a little bit flatter here at the vertex area. All right, so that's our parent function, but now we wanted to do x plus 2 to the fourth. Let's check that first. So I'm pushing tab, and I want to do x plus 2 raised to the fourth. So does that indeed shift it left 2 units? Sure does. There it is. But now we really wanted a negative in front of this, so let's do that. Let's make that change. I'm going to go up, and I'm going to edit this and just put a negative in front. And there it is, reflected over the x-axis. It's been shifted 2 units to the left and reflected over the x-axis. What about this next example? We have, whoopsie, we have, give myself a little bit more space here. if we have the original parent function x to the fourth and we want opposite of x to the fourth plus 2, well, is that going to be the same? I still see an opposite and I still see a plus 2, but let's compare. This time we're doing x to the fourth first and then we're doing the opposite of that. So that's still a negative in front of the whole function, right? Or at least this parent function. So this is still going to be a reflection over the x. But this time I see a plus 2 at the end, so that should be a shift which direction? Up, down, left, right? It's not in with the x like it was up here. It's at the end of the function, so I would say that's going to be a shift up 2. All right, let's check this on our calculators. Let's see, we want opposite of x to the fourth. I'm going to get rid of this last example. Actually, let me just add a new page so we keep all the record of what we're doing. We want x raised to the fourth as our parent function. There it is. And we want negative x to the fourth. So I'm going tab, I want negative, and then x raised to the fourth. That's that reflection over the x-axis. And we want to add 2 to that function. So we're expecting that to shift up. Let's do a plus 2. Sure enough, it shifted that graph up 2. Are we okay with this? I hope we're okay with this. All right. And so that's reflecting and putting some things together. All right, let's take a look at this next example. It says describe the transformation needed to achieve each of these graphs from the parent function. So if we have f of x equaling square root of x, j of x equaling square root of negative x, and g of x equaling square root of x plus 2. Describe the transformation needed to achieve these graphs. So we have square root of x would be, and by the way, if we're plotting square root of x, it goes through 0, 0, 1, 1, 2, 3, 4, 2, and 9, 3, right? Those would be the key points for this parent function, x versus square root of x, 0, 1, 4, 9, would get me 0, 1, 2, 3. So I just plotted those points. But if we want to take the opposite of square root of x, I'm sorry, square root of opposite of x, I didn't say that right. Square root of opposite of x, where we're taking the opposite of x first, then that is going to be a reflection over the y-axis. All right, and so that should look like this, and let's see, negative 4, 2, and negative 9, 3. That should look like this one here. Okay, and what about our square root of x plus 2? That plus 2 is in with the x, so that should be a shift, left or right, and in this case it's to the left 2 units. All right, so that graph should look like my original parent function here, but shifted left 2 units. So it should look something like this. Let me put those points in. That's going to be here, here, let's see, 4 up, 4 over, 2 up, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 up and 3 over. So it looks something like this. All right, let's check this on our calculator. So these are the graphs that we're verifying. Square root of x, I'm adding a new page. I want square root of x. That's my parent function. And next up, I wanted square root of negative x. So I'm doing square root negative x. That's that reflection over the y-axis. And then we also want to do square root of x plus 2 to verify that we're doing everything correctly. So if I go tab and square root of x plus 2, there's that graph that has been shifted 2 units to the left. All right, here's another example. What if we have opposite of square root of x? Well, the parent function should look like, the parent function would be f of x equaling square root of x. That's that graph that goes through 0, 0, 1, 1, 4, 2, 9, 3. Right? But if we want opposite of square root of x, That's going to be a reflection, but which axis is that reflecting over? That's reflecting over the x-axis, so that one should be going through 0, 0, 1, -1, 4, -2, 9, -3, like this. And again, you could verify this on your calculator. Let me just add that to this same mix here, and I'm doing negative square root of x. And there it is reflected over the x-axis from our original parent function. All right, what about negative square root of x minus 4? For that one, we would have a shift. The x minus 4 would be a shift. What direction? Up, down, left, right? Since the minus 4 is in with the x, it's a shift left or right. And since it's minus 4, we're going to the right 4 units. And then this negative out in front here means that it's a reflection. That's out in front of the whole function, so it's a reflection over the x-axis. All right, so I would predict that our parent function, f of x equaling square root of x, we know that that looks like this. Hopefully you're getting fast at plotting these. 9, 3, so parent function looks like this. And then we're going to shift that to the right 4. So that's going to put it 1, 2, 3, 4. Something like this. And now we want to reflect it over the x-axis, so I think our final graph would look something like this. I'm trying to get some accurate points for us to plot. So I think right here, this function would be our final answer for this. Let's verify that on a calculator. So we want negative square root of x minus 4. Let's put our parent function in first. And we want negative square root of x minus 4. Negative square root of x minus 4. And there it is. It's been shifted 4 units to the right and then reflected over the x-axis. All right. And let's do just one more of these. Yep, let's just do one more. On this one, we have x plus 3. The x plus 3 here indicates a shift. Which direction? Up, down, left, right? If it's in with the x, the plus 3 is in with the x underneath the square root, that's going to be a shift left 3 units. All right, this negative out here is going to be a reflection over the what? Well, it's outside of the whole function, so it's a reflection over the x-axis. And then this plus 2 here would indicate a shift. Since it's on the outside of the function, it's not underneath the radical, it's not in with the x, that would be a shift up 2 units. So our parent function, let's say, is here, 4, 2, 9, 3, and so I plot that, and then I want this graph to be shifted to the left 3, and I want it reflected over the x-axis, and then shifted up 2. So I think that that means the graph will be shifting left 3 and reflecting over the x-axis would put me at something like this. And then I want that whole thing shifted up 2. So I think our final graph would look something like this. All right, let's check this last one on our calculators to see if it looks like that final blue graph that I have there. I hope it will. Let's see, I'm going to go to this one. I'm just going to take out that last function that I typed in, and I want negative square root of x plus 3. So I got the negative there. Square root of x plus 3. And then outside of this, I want plus 2. That's on the outside. And there it is. That looks pretty much like our graph that we drew here in blue. All right, so that's it for this lesson. And you have some homework to do, and thanks for watching.